In this video, I'm not going to get into the details of how to write automated tests or any of the details behind implementing automated testing. Instead, I'll be discussing code coverage tools and how they can be used both correctly and incorrectly. As a result, this video is appropriate for software developers at all levels, but it's also appropriate for managers who want to understand how to improve the productivity of their teams. A code coverage tool analyzes automated tests to determine how much code is actually exercised by the tests. They exist for most, if not all, programming languages and have varying feature sets. At the minimum, however, they will provide a number indicating what percentage of the code is being run by automated tests. The easiest way to use code coverage tools incorrectly is to place any sort of significance on the overall coverage percentage. I've heard stories of companies that require a certain coverage percentage before allowing new code into their code base, and this is even worse. Let me explain why this is a bad thing. Here we have an example function. Don't worry if you're unfamiliar with the Go language. The important thing to notice is that this function takes 3 numeric input values, does some math on the inputs, and returns a numeric result. There are no branches within the function, meaning it executes the same calculations regardless of the input values. Here's an example test. Again, don't worry if you're not familiar with Go's testing framework. The important takeaway is that most anyone would agree that this is a terrible test. It doesn't even assert that the function returns the correct answer. However, a code coverage tool will report that the function is 100% covered by tests. While this oversimplified example seems almost silly, I've found this particular pattern in testing quite common. I've seen large test suites that do nothing but execute code without ever checking that the code actually did the right thing, and coverage tools report excellent test coverage. To provide some contrast, this is what I would consider to be a minimal acceptable test for this function. Again, the details of Go's testing framework aren't important. The important details are that a range of values are used as input, and each case checks that the correct output was received. This leads to one obvious conclusion. A high percentage of test coverage does not demonstrate that a code base is well tested. As a result, coverage percentage should never be used in any way that can be construed as determining test quality. Furthermore, it should never be used to dictate policy. One possible cause for this lies in the developer. Perhaps the developer doesn't actually know how to write good unit tests. Reviewing the coverage percentage does nothing to help identify that the developer needs training, nor does it protect the organization from this developer's blind spot. Worse still, it might give the developer the mistaken impression that they're testing correctly. As a result, code coverage could actually make the organization's testing worse by encouraging the creation of tests that appear to be of good quality and are fast and easy to implement, but actually border on useless. Another possible cause lies in the organization. A lot of developers are under significant pressure to produce code on tight deadlines. Even an experienced developer, when stuck between contradictory requirements of meeting a deadline and maintaining high code coverage, may resort to code like this. The biggest problem in this case is that doing so negates any future value of the coverage tool to identify or remedy the shortcoming. If the developer had simply left the code untested, then when more resources became available, the coverage tool could be used to identify what testing was skipped because of tight deadlines. And this provides a segue into the correct use of coverage tools. Coverage tools are just tools and only provide value if used correctly. While they are not able to identify well-tested code, they are very good at identifying when the code isn't tested at all. I'll demonstrate with the Go coverage tool. In addition to the raw percentages, the tool provides details of exactly which lines of code were and weren't executed. In this example, you can see that an entire branch of this function was not tested at all. This is a fast method to determine when additional test cases are needed. It's not a complete solution, but simply one tool to help expedite the process. To bring this to a conclusion, first, code coverage percentage should never be used to judge test quality, and certainly not to restrict which code can be incorporated into a code base. Second, code coverage line-by-line reports help code reviewers and developers identify where additional tests may be needed. They are one of many useful tools, but not a complete solution.